Alright, the benzene ring problem. We have two benzene rings here, and they are floating somewhere in space. So a benzene ring, of course, is just a hexagon. And the problem posed to me by my friend was they're trying to figure out what if you have two benzene rings floating here in space, and if one's over another one, maybe like this here, they have certain properties, and what they're going to define as stacked. And I don't know all the chemistry behind it, but his goal is he's got to figure out if you have them stacked, how can you tell if they're stacked? So we're only given the coordinates for all six: x1, y1, z1 for all six coordinates, and xa, ya, b, za for these six on this one. We need just for arbitrary numbers, because they could be anywhere in space. They could be like this. They could be over here somewhere. Could be one way up high, one way down low. But we need to figure out if, as you're looking down on one of them, what percentage of this is going to cover up this one down here. So, now because of the tilt, though, it might be like this, where there's only a very small percentage of it, or it might completely cover it, or maybe they're side by side. But he needs a mathematical way using three-dimensional coordinate geometry to figure out what percentage of the area of this one right here is covered by this one up here. Or if you could think of these in colors, if this were green and this were yellow, if this one were to pass through this, what percentage would be green? Sorry, if this one were blue, this one were yellow, if this one were to pass through it, what percentage would have ended up being green? So that's the benzene ring problem. You only have the basic operations to use. So sine, cosine, tangent, square roots, addition, subtraction, multiplication. We need to figure out a way to tell if what percentage of this covers up this one down here. Once we have that, we can give that to him, and he will figure out a way to tell if something's stacked or not. But we need to figure out what percentage of them, what percentage overlaps, or even just what's the area that overlaps. That would work too. So that's the benzene ring problem. It's somewhere in three-dimensional space. It could be over here, like this, and we have to pass this one through it like this. But what projection is going to cover it?